In this episode, we're going to look at how to use N4ce for point cloud extraction on the typical features found in a road corridor survey. A shout out to Riegl for supplying this data of downtown Orlando that was captured with their VMY-2 MLS system. Now, there's a bunch of ways to digitize road corridor data in N4ce. There's automatic feature extraction, there's digitizing on an ortho, there's working on the point cloud in 3D or in 2D sections. Most of the time, I end up using a combination of these techniques to get a project across the finish line. The first thing I'll do is classify the ground points that are about half a meter or so off of a DTM created using the ground mesh tool, then export a scaled orthophoto using the geo image tool. I went over this method in detail in episode 3 of this course. Unfortunately, this particular dataset wasn't colorized, and as such, I have to visualize it by intensity, which means I lose a lot of nuance in the data, but we can still use the orthophoto method to a degree. Now that I have an ortho, I can jump into the 2D model view, select insert points, and digitize the top of curb using model interpolation and sample the highest point in the point cloud. I'm looking to see where there's a line of points spaced tightly. Since this is the top-down view of points, that line represents the vertical face of the curb. By picking right behind that, I can fairly accurately define the top of curb. N4ce just very recently added the ability to use comma code keyboard shortcuts in the model view so that I can add curves directly in the insert points tool as long as I check this box here. I also need to make a correction to something I said in a previous episode. When starting and ending a tangential curve, which is most of the curves we'll be working with, you should use the shortcut T, not C. T is meant for tangential curves that lead into straight segments. And I should mention, when using the tangential curve comma code, you can define a curve with only 2 clicks as long as it has a constant radius. And a quick reminder, we can use our auto pan feature to keep our view centered on our clicks, which is handy for these linear features. The shortcut for this is Alt A. Now that's looking pretty good, and it only took me about 5 minutes or so to digitize half a kilometer of curb, but I still have to deal with my gutter line and back of curb. Because the intensity values do a poor job at delineating these features, I'll switch over to the 3D viewer and use the parallel tool in there. I'll pick my line, pick a point on the feature I'm trying to create, in this case gutter line, set my model interpolation to use the lowest, and now we have that gutter line defined. I'll repeat that process for the back of curb, and that wraps up the curbing here. This method is extremely fast when you have dense, clean data to work with, especially if it's colorized. But is it the most accurate method in the world? No, not really. We're more or less assuming all these features have a constant horizontal offset, which in reality we know is not always the case. Now we can parallel only certain parts of each line or do manual cleaning after, but if we have less than optimal data or want to make sure every single point is just about as perfect as it can be, we can switch over to working in the 3D viewer. For sectioning along a linear feature like this, there are quite a few different ways to set up the section I'll use to pick out the features I need to extract. I can use the multi-plane section tool to pick vertices that define the path that the section will follow. I can digitize one feature down the corridor, like top of curb, either on the ortho or directly in 3D, and use that as our section path. Or I can rough in a temporary line that runs down the center of road, more or less the same way I use the multi-plane section tool, but this way I can add in curves, which is really helpful if your road isn't just a straight line, and especially if there is a road marking on center line that needs to be digitized anyways. For this example, this is the route I'll take. Once I have my center line, I can use the selection along feature tool. I'll set up my section interval to a value that makes sense so that I can jump the section along that line using the greater than or less than keys. We'll click the Select Points tool in the Digitize tab, enter in a code, and click the Add Code button to add it to our quick codes. I'll repeat this until I have all my codes that I want to use stacked up. Then make sure Free Select is ticked on, and I'll use my quick codes to pick out each feature in the cross section. I'll jump ahead to the next section and repeat the process. When you come to a radius that your section path doesn't follow, the cross section of points will spread out, making it hard to accurately define the feature because your section is no longer perpendicular to it. What I like to do is turn on the section plane distance display modifier, and the points colored in green are the true center of your section, which allows you to digitize features on curves while remaining in the section. And of course, to finish out a radius or curve, we can always just close the section view and start picking points in 3D. While we're looking at this curve, we can see the curb is actually changing elevation faster than our line work depicts. The densify tool is great for fixing this. I'll use a maximum distance of 50 centimeters here, set my model interpolation to highest, and now we can see that line work follows the point cloud much more closely. There is a technique to speed up this quite a bit. Let's redo this section, but this time we'll use the same code for every feature. As we do this, we're creating a kind of zigzag line. And then we'll use the zigzag tool in the editing tab, click the line we just made, and enter the number of features we were trying to digitize, and it turns that one line into individual strings. Then just click the recode button and click the lines you need to recode. Now, while this isn't as fast as digitizing on an ortho, it's significantly more accurate. The key to efficiency and quality in N4ce is to mix and match techniques to best fit your data and your desired accuracy. If you're working your way along in the model view and come to a part of the data where some features are hard to pick out in 2D, ideally the 3D is open on your other screen and you can immediately switch over to picking them out in there. If we want a method to increase efficiency while still working in the 3D view, we can explore the automatic feature extraction tools. There are tools for road paint lines, highway barriers, walls, and curbing. Let's extract some curb to see how it works. Enter the Feature Extraction tab, click the Wall and Curb Extraction tool, make sure the Extract mode is set to Curb and the Edge mode is set to Top. I've edited my curb lines preset a bit, so if you're struggling to get decent results, I'd recommend taking a screenshot of what I'm using as a starting point, and if you press the F1 key on your keyboard, you'll be brought to N4ce's help portal, and then just type in feature extraction variables and navigate to the article that explains in detail what each of these settings does. If you've watched my episode on power line extraction, this should all be fairly familiar. Click the Add Seed button and place it on the top of curb, holding Shift to add more seeds as needed. Set a code and click Extract. If it seems like it's worked okay, click Commit All and clear seeds, and in the Editing tab, use the String to DTM tool and move that line up to the highest point within 5 centimeters or so, just in case the extraction tool didn't pick out the top elevation perfectly. Quick tip, whenever moving to the highest point like this, it helps to turn off non-ground points. Then just rinse and repeat, add a seed, extract that seed, commit that seed, then clear the seed and move the line to the DTM. We can QC our results using the Section Along Feature tool. This automatic extraction process does a pretty damn good job, but just like any auto extraction tool, it will take some cleanup, so it probably won't make sense to use this on curbing that has a lot of letdowns or sharp curves, but for long stretches of uninterrupted curb line, it can save quite a bit of time and effort. Then to finish off the curbing, we can switch the edge mode to bottom and set seeds in the gutter line. It works great here as well, or of course we can just use the parallel tool in the same way we did previously. Discrete features like manholes, lampposts, catch basins, bollards, simple trees, and traffic signs can all be picked out extremely fast in the 2D ortho mode. Nothing too new here. People have been doing data extraction on orthos for over a decade now, but being able to do accurate elevated feature extraction on the ortho is just fantastic. For building footprints, fences, or walls, I can either cut a vertical section and work in there, or again jump back into the ortho. You can play around with the height of the points you want to sample for that ortho image too. This time I only went up half a meter, but sometimes I'll sample points as high as 2 meters, just enough to remove any trees or overhead obstructions, but you still retain pretty much everything you want to extract. And a quick tip, In either the section view, 2D model view, or 3D view, double-clicking the mouse wheel will zoom extents. And likewise, in each view, if you hold Shift while digitizing, it will snap orthogonally or at 45-degree increments. And if you've already picked 2 points while digitizing, it will snap perpendicularly to the last 2 points in your line segment. Road markings can be done in 3D or 2D. If I use the road dashes line in the model view and combine that with a point code that had alternate segments ticked under the line tab, I can quickly auto dash road lines. This would be a good time to point out when we activate a tool that requires multiple steps, we get instructions on what to do next on the lower left hand corner of the screen. And for road lines, we can also adjust our code style, and namely the line width, to more closely represent what's on the actual ground. If we want to add typical road lettering, we can set up a code that has a choice list text field, not too dissimilar to what we did for trees, but this time we'll enable text and use 3-point alignment so that when we insert points in the model view, ticking add point attributes in attributes on first only, when we click the first point, we get prompted to pick one of the text options we set up in our choice list just a minute ago. Here I'll choose bus, and since this code is set up for 3-point alignment, I need to define the width with another point and the height with that third point, and the text we chose is automatically scaled to fit those 3 points. We can also create custom symbols and assign those to a specific code in the code list, and scale those symbols using a variety of methods, in this case by clicking 2 points that we assign to be handles of our symbol. When I do this, I can quickly draw traffic arrows, HOV diamonds, crosswalks, etc. I'll cover symbol creation more in the next episode and how to migrate your existing AutoCAD symbols into N4ce. When it comes to driveways, sidewalks, etc., meeting the road, there are a bunch of different ways to get lines to intersect each other. Most of the good tools for this are in the Model View in the Lines tab. If I use the Extend to Reference Multi option, I can set one line as my reference, back of curb for example, and every other line I pick after that will be extended or pulled back to meet it. If I want to trim a line, it doesn't quite work the same way AutoCAD does. We can break lines, but since N4ce is drawing lines between points in a model, we must first add points at the intersections that we want to retain. We can use the Extend Merge and Join tool to connect abutting lines, or the Join tool to, surprise, surprise, join lines. If you want to run a tool on multiple lines at once, you can add them to a list. This is more or less just like picking a bunch of entities in AutoCAD. And if you switch your pick mode to list, it will run the function on your selection. Well, that wraps up this episode. You should now have all the basic tools available to you to start extracting features from a point cloud and digitizing line work. All that's left is plotting a drawing that you can deliver to your client. Make sure to stick around for the 10th and final episode of the Beginner to Pro series in N4ce.